Hi guys, welcome back to the channel. So we're going forward for DP. Let's see what is it about. Read code 337 house robber 3. It's a medium level problem. The thief has found himself a new place for his thievery again. There is only one entrance to this area called root. Okay. Besides the root, each house has one and only one parent house. After a tour, the smart thief realized that all houses in this place form a binary tree. It will automatically contact the police if two directly linked houses were broken into on the same night. Given the root of the binary tree, return the maximum amount of money the thief can rob without alerting the police. So if we go to the first house and leave the second there and go to the third, or from here go to the first one, and we have one thing: either we do robbery or we don't. So let's do one thing. Max amount, right? So we go to each layer. You can do DFS. You can do it in BFS approach. So the first one is it will automatically contact the police if two directly linked houses were into the same broken into on the same night. So if we select this, we cannot select. So if we select a parent house, we cannot select the child, and if we select the child house, we cannot select the parent. So let's do one thing. Uh, First way and the second way is 0. Let's keep q equals to and is alternate is false while q equals to length of the queue for in range of dot top left. If node dot right, open the right node, or else, I mean, not else, and the left node. So we open the left and right nodes, and here let's keep your alternate W2 equals to let's see the constants 2. Node values in between 0 and 10 to the power of 4. That's something fishy, guys. So I think this is going to work fine, but it is not still the correct answer. Well, it is said that two directly linked houses cannot be broken once, but we can select the root node and leave that next two set of nodes and can select the third layer one. In that case, not as simple as we think. Let's go through it anyway. Is alternate. Let's flip the is alternate to of environment. Well, this may have worked, but this is not the answer. So, the perfect solution, because we can still choose the first node and leave the next two nodes and select different node entirely. Like, for example, I will give an example. So here we have 10, 4, 5, 1, 3, 2, 4, and 14. So if we draw the lines just like this, but in this case, we have to select 10. So we don't like, we cannot select, we can select 10 and we should leave 4 and 5. We can select 3, 2 and 4, and we can select 14. Now 24, 24 and 4, 28 and 5, 33. But how do we do it? One thing we know for sure is we cannot select adjacent nodes. What should we do? Maybe you have to go through all possible ways. Then we have, the first thing is either you can select a node or you cannot select a node. If you select 10, then you cannot select 4 and 5. Or if you select 4, you cannot select 10, 1 and 3. And if you select 5, you cannot select 10, 2 and 4. You can select 3, you can select 1, and you cannot select 4 and 14. Or you cannot select 1 and go to the 14 directly. But one thing is, you would either select a node Like the distance between two selected nodes will be either 2 or 1 at max. It won't be greater than 2. Let's see how can I deal it. Let's see the topics. There are no hints to let's see the topic anyway. So DFS. Let's create a new chart. This is my initial draft for keyboard 337. So, but I noticed, I noticed a problem here. One is we can the distance between selected nodes can be the number of non nodes related nodes can be to the max I can use a DFS approach with an argument or not. Mm, but mm, 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 but but max help me to figure it out. Mm, no, clusters. And basically, it's because the house over three doesn't follow the will exclusively. It's about parent child adjacency. So legal alteration doesn't capture all valid knowledge and node sets. Each node has two positive states. If we rob this node, we cannot rob its children. If we skip this node, we can rob or skip its children optimally. So each recursive step returns two values for each node. Rob this node value plus skip left, skip right. Skip this equals to maximum of rob left and skip left. Maximum of rob right and skip right. It's the standard vertically approach. He gave the answer. Anyway, we have to see it at some point because this is not the optimal way and I cannot think of a way. So if not node return 0, 0. Oh, left equals to left and then right. We'll check rob this equals to node dot value plus left and then right. Keep equals to maximum of left plus we select the maximum of left and right. And why are we selecting the first one? Okay, guys. The sum of we are taking the maximum of robbed and skipped values. We are adding the maximum of left and right. Initially it should be 0. You take the maximum of the both and return robbing or skipping it. But without just giving try to store for each node value parent can drop parent. If parent is robbed, skip current node. Else pick maximum of rob plus gain child. Skip plus child. Uh, well, let's implement it. DFS. If not, no. Taking the current node value and we're adding the max. Sorry, for left. Only the robbing one is the skipping one. Maximum of left plus maximum of returning will get the skipping values as the maximum. Select the current node and take the skipping value from the left and right. Why? Because we can choose the skipped values of the previous layer. So we are choosing the skipped values. Adding skipped values of we are skipping the maximum value so that we can drop it later. Well, this is working fine, but this is way more complicated to think. chance to rob 3 and lateral select 2 to rob and skip 3. Okay, wait a minute. We go to the 3, robbed 3. We go to 1, here we skipped 1. God. Oops. 0, 0. And skipping 3. Skipping 2 and skipping 3. Selecting 3 and skipping 1. Now we are selecting let's see if it is working. Let's see other solutions first to understand. This node is in scene. We are doing the scene of node, and scene by the way is a dictionary. With node, without node. With node dot value comma 0, and without it is 0. Node dot value and 0. If there is a right, I mean left, we are not going to select Since we selected the current node, we are not going to select the node dot left, but we are going to select the left dot left. Same here too. What they said is true. EDP is not simple. Let's take a little break. Let's ease our mind and come back later so that we'll learn with a peace of mind. A peaceful mind, actually. When I'm back, to put it simple, so we break in the middle of explanation. So to put this into simple words, we are strategically taking the current node and the previously skipped nodes, and this is a strategic approach where skipping is a greedy approach where the current node can be we can either select or like we are taking the maximum of selecting or not selecting from the node. So I hope you guys understood the intention. So it is basically two approaches at a time: a strategic approach and a what do we call it? Greedy approach. And we are taking one of them finally. That's it, guys. I hope you guys like the video. If you liked it, upvote it and share it with your friends, and don't forget to subscribe the channel. We'll meet you again with another video. Until then, keep learning and keep pushing on.